What if I told you that one of the world's most mysterious perfumes once came from a small nocturnal animal called the musk cat? This quiet forest wanderer produces a powerful scent used in luxury fragrances, and it can also choose the ripest coffee cherries in complete darkness. Tonight, let us gently follow this remarkable creature into its hidden world. The quiet stranger in the night. Just imagine this for a moment. The forest is completely dark, the air is warm, and somewhere above you, a small animal is moving silently through the branches. You cannot see it clearly yet, but two bright eyes are watching from between the leaves. This mysterious creature is often called the musk cat. Despite its name, it is not truly a cat. It belongs to a remarkable group of mammals known as civets, animals that seem to combine the features of several familiar creatures. A musk cat may have the graceful body of a feline, the pointed face of a fox, the climbing ability of a marten, and the long tail of a tree-dwelling explorer. It looks familiar and strange at the same time, as though nature created it from several different ideas. One of the best-known animals called a musk cat is the Asian palm civet. It lives across parts of South and Southeast Asia, from tropical forests and plantations to villages and the edges of busy towns. During the day, it usually remains hidden. It may sleep inside a hollow tree, beneath thick vegetation, among rocks, or in the dark space beneath a roof. But when evening arrives and the world becomes quieter, the civet begins to wake. Its large eyes are specially suited for darkness. Like many nocturnal mammals, it can use very small amounts of light to move through its surroundings. Moonlight filtering through the leaves may be enough for it to recognize branches, fruit, insects, and possible danger. Its rounded ears remain alert to every faint sound, the flutter of a moth, the movement of a lizard, or the sudden call of a bird disturbed from sleep. The musk cat is usually a solitary animal. It does not move through the forest in a noisy group. Instead, it travels alone, following pathways that may be known only to itself. It walks carefully along branches, placing each paw with surprising precision. Its tail helps it maintain balance as it crosses narrow spaces high above the ground. To a human observer, its movements may appear slow and cautious, but this careful pace is exactly what makes it such an effective nighttime survivor. Its diet is wonderfully varied. Musk cats are omnivores, which means they can eat both plant and animal foods. They may feed on sweet tropical fruit, berries, seeds, insects, frogs, small reptiles, eggs, or tiny mammals. Their flexible diet allows them to survive in changing environments. When one kind of food becomes scarce, another may be available. Fruit is especially important to many civets. A musk cat can detect the scent of ripe fruit in the darkness and climb toward it with quiet determination. After eating, it may travel some distance before the seeds pass through its digestive system. In this way, the animal unknowingly carries seeds away from the parent tree and deposits them in new places. Some of those seeds may eventually grow into young plants. So this secretive nighttime visitor is also a gardener of the forest. The name musk cat comes from the strong-smelling substance produced by scent glands near the base of the animal's tail. Civets use scent as a form of communication. A smell left on a branch, rock, or tree trunk can carry information long after the animal has moved away. It may mark a familiar route, signal that a territory is occupied, or help one civet detect the presence of another. For humans, this scent became famous for a very different reason. For centuries, a substance known as civet was used in traditional perfumery. In tiny quantities, it could help a fragrance last longer and develop a deep, warm character. Unfortunately, collecting natural civet often caused suffering to captive animals. Today, ethical perfume makers can use synthetic alternatives, allowing similar scents to be created without harming wildlife. The musk cat has another unusual connection with people. The Asian palm civet is linked to kopi luwak, a coffee made from beans that have passed through the animal's digestive system. Civets naturally choose ripe coffee cherries, digest the soft fruit, and later leave the beans behind. These beans can then be cleaned, processed, and roasted. This story has made kopi luwak famous around the world, but it has also created serious animal welfare concerns. In some places, civets are kept in small cages and fed large quantities of coffee cherries instead of being allowed to search naturally for a varied diet. The romantic image of a wild civet choosing fruit beneath the moonlight can be very different from the reality of commercial production. For this reason, responsible consumers and conservation groups encourage people to question how such coffee is produced. In the wild, the musk cat does not exist for coffee, perfume, or human curiosity. It has its own ancient life, shaped by millions of years of evolution. Every feature of its body has a purpose. Its sensitive nose helps it locate food and recognize scent markings. Its sharp claws help it climb. Its teeth can handle fruit as well as small prey. Its dark or mottled coat helps it disappear among shadows, branches, and leaves. Even the civet's silence is a survival tool. In the nighttime forest, noise can reveal the location of both predator and prey. By moving carefully, the musk cat can approach food without attracting too much attention. It can also avoid larger hunters such as big cats, snakes, birds of prey, and humans. Yet the life of a musk cat is not completely silent. Civets can produce a range of sounds, including growls, hisses, squeaks, and calls used during stressful encounters or communication. Young civets depend on their mother and may use soft vocalizations to remain in contact with her. But most of the time, scent and body language are more important than loud calls. There is something deeply fascinating about an animal that can live close to people and still remain almost invisible. A musk cat may cross a garden, walk along a wall, or search for fruit near a house while everyone inside is asleep. By morning, it may leave behind only a few paw prints, a disturbed branch, or the faint remains of a meal. Perhaps this is why the musk cat feels so mysterious. It occupies the hidden hours of the night, when familiar places become quieter and less certain. While humans rest, the civet explores a second world, a world of scent trails, moonlit branches, ripe fruit, and sounds too faint for us to notice. And as we continue our journey, we will discover that this calm-looking creature has an extraordinary history. Its ancestors lived long before modern cities, coffee plantations, or perfume shops existed. To understand the musk cat fully, we must travel backward through time and explore how civets evolved into some of the most adaptable and secretive mammals of the tropical world. An ancient family hidden in plain sight. Long before cities glowed at night, long before coffee farms covered tropical hillsides, and long before humans gave it the name musk cat, the ancestors of civets were already moving quietly through ancient forests. To understand this unusual animal, we need to travel far back in time. The musk cat belongs to a broad group of mammals within the order Carnivora, the same major branch of the animal family tree that includes cats, dogs, bears, hyenas, mongooses, seals, and many other predators. But the civet followed its own evolutionary path, developing a combination of features that made it especially well suited to life in warm forests and after-dark environments. The name musk cat can be misleading because civets are not true cats. Domestic cats, lions, tigers, and leopards belong to the family Felidae. Many civets belong to the family Viveridae, while some animals commonly called civets are placed in closely related families. Their bodies may look feline at first glance, but their skulls, teeth, scent glands, behavior, and evolutionary history reveal that they are something different. This is one of the most interesting things about evolution. Nature often creates similar body shapes in unrelated animals when they face similar challenges. A slender body is useful for moving through dense plants. Sharp claws help with climbing. Forward-facing eyes improve depth perception. A long tail supports balance. Because these features are useful, they can appear in different branches of the animal kingdom. A civet may therefore resemble a cat not because it is one, but because both animals benefit from being agile, quiet, and alert. The earliest carnivorous mammals appeared tens of millions of years ago. They were generally small, flexible hunters that lived in a world very different from our own. As forests expanded and climates changed, different populations adapted to new food sources and habitats. Some became powerful runners. Others became swimmers, diggers, or large predators. The ancestors of civets remained relatively small and versatile. Versatility became their greatest strength. Instead of evolving into animals that depended on one type of prey, many civets developed broad diets. Their teeth could cut animal tissue, but they could also crush insects and process soft fruit. Their paws were useful on the ground and in trees. Their bodies were small enough to hide in narrow spaces, but strong enough to travel considerable distances during the night. This flexible design allowed civets to survive where more specialized animals might struggle. The Asian palm civet, one of the best-known musk cats, is a perfect example of this adaptability. Its body is long and low, with relatively short legs and a tail that may approach the length of the head and body combined. This shape helps it move along branches and squeeze through vegetation. Its face is pointed, giving it room for a highly developed sense of smell. Many palm civets have dark markings around the eyes and face. These patterns can make the animal look as though it is wearing a small mask. The rest of the coat may be gray, brown, blackish, or a mixture of muted colors. These shades blend beautifully into tree bark, shadows, dry leaves, and nighttime forest backgrounds. Other civets look very different. The African civet is larger, with a strongly patterned coat of spots, stripes, and dark bands. Some species are almost entirely dark. Others have pale bodies covered in marks that break up their outline. This diversity reflects the wide range of environments in which civet-like animals have evolved. They can be found in tropical forests, woodlands, savannas, plantations, rocky areas, and even near towns. Some spend much of their lives in trees. Others travel mainly on the ground. Some are fruit specialists, while others eat more insects, small animals, or carrion. This variety can make the term musk cat confusing. It is a common name rather than a precise scientific label. In different countries, people may use it for different species. The Asian palm civet is often called a toddy cat, palm cat, or luwak. The African civet may also be described as a musk cat because of its scent-producing glands. The small Indian civet and large Indian civet have their own regional names. Despite these differences, many civets share several important traits. They are mostly nocturnal or active during twilight. They possess an excellent sense of smell. They often live alone outside the breeding season. They communicate with chemical signals. And they tend to be cautious, secretive animals that avoid unnecessary conflict. Their scent glands are among their most distinctive features. Located near the base of the tail, these glands produce substances used in communication and territorial marking. To another civet, a scent mark is not simply a smell. It may contain a detailed chemical message. It can reveal the species of the animal that left it. It may suggest whether the animal was male or female. It can provide clues about reproductive condition, individual identity, and how recently the mark was placed. In a dark forest, this chemical language is extremely useful. Sight becomes less reliable at night, and loud calls can attract predators. Scent remains after the animal has gone. It allows civets to communicate across both distance and time. Humans often imagine communication as something that requires sound, but the natural world is filled with silent messages. An animal may read the environment through its nose just as we read words on a page. The civet's sense of smell also guides it toward food. A ripe fruit releases a mixture of aromatic molecules. To us, the smell may be faint or pleasant. To a civet, it can act like a signal glowing in the darkness. The animal follows the scent through vegetation until it finds the source. This ability may explain why palm civets often choose particularly ripe fruit. Their noses allow them to detect subtle changes in sweetness and fermentation. They may reject unripe fruit and return later, when it contains more energy and is easier to digest. Civets are also curious and intelligent. In human-modified environments, some learn to search orchards, rooftops, gardens, rubbish areas, and farm buildings. They remember routes and locations where food has been found before. They may return to the same fruiting tree on several nights. This does not mean they are tame. A wild civet remains a wild animal. If frightened or trapped, it may bite, scratch, hiss, or release a powerful odor. Its quiet appearance should never be mistaken for helplessness. Like many small predators, the civet survives by avoiding danger whenever possible. Fighting consumes energy and may cause injury. A broken tooth, wounded paw, or damaged eye can become life-threatening in the wild. Caution is therefore not weakness. It is a highly successful survival strategy. The evolutionary story of the musk cat is a story of balance. It is neither a powerful big cat nor a defenseless fruit eater. It is neither fully arboreal nor entirely ground-dwelling. It is neither strictly carnivorous nor strictly vegetarian. It lives between categories. That may be the secret of its success. When forests shrink, some civets move along field edges. When natural fruit becomes scarce, they may search cultivated plants. When one prey species disappears, they can switch to another. This flexibility has helped several species remain widespread even while many other animals have declined. But adaptation has limits. Roads, hunting, wildlife trade, habitat destruction, and intensive farming can place enormous pressure on civet populations. An animal that can tolerate some human activity may still disappear if its environment changes too quickly. The musk cat has survived millions of years of natural change, yet the modern world is transforming its habitats at an extraordinary speed. For now, imagine it again in the ancient forest. The air is heavy with moisture. Giant leaves catch drops of rain. Insects hum beneath the canopy. Somewhere above the ground, a small civet steps onto a branch and pauses. Its body carries the history of countless generations. Its long tail steadies it. Its nose tests the air. Its eyes collect the faintest traces of light. Then it moves forward, following a path shaped by instinct, memory, and millions of years of evolution. In the next part, we will follow the musk cat into its nighttime world and discover how its senses allow it to see, hear, smell, and navigate in darkness. A world built from darkness. For us, darkness can feel empty. Shapes disappear, colors fade, and the world seems to become smaller. But for a musk cat, night is not an absence of information. It is a different kind of world, filled with scent, vibration, movement, and quiet signals that humans barely notice. As the sun sinks below the horizon, the tropical forest begins to change. Daytime birds settle into the canopy. Insects grow louder. Bats rise into the air. Leaves cool, flowers release stronger scents, and small creatures begin to move through the undergrowth. This is the hour when the musk cat becomes fully awake. Its large eyes are among its most important nighttime tools. Like many nocturnal mammals, the civet has visual adaptations that help it use very low levels of light. The pupils can open widely, allowing more light to reach the retina. Even a faint glow from the moon or stars may be enough to reveal the outline of a branch, the movement of an insect, or the shape of ripe fruit among leaves. But night vision is never perfect. The world seen by a civet is not bright and colorful in the same way as daylight. Fine details and colors may be reduced, while movement and contrast become more important. A pale moth crossing a dark background can be easier to detect than a motionless object nearby. The civet's eyes may also appear to shine when light falls on them. This effect is caused by a reflective layer behind the retina called the tapetum lucidum. Light that passes through the retina can be reflected back through it, giving the light-sensitive cells another chance to respond. This improves vision in dim conditions and creates the familiar glowing eye effect seen in many nocturnal animals. Still, eyesight is only one part of the civet's sensory world. Its sense of smell may be even more important. A musk cat does not simply smell a forest as one general scent. It can separate many layers of information. The air may carry the sweetness of ripe fruit, the earthy odor of wet soil, the scent of another civet, the warning smell of a predator, and the faint trace of an animal that passed hours earlier. The civet often moves with its nose slightly forward, sampling the air. When it lowers its head to the ground or presses its muzzle near bark, it is gathering chemical clues. A place that looks ordinary to us may contain a detailed history written in scent. Another civet may have rubbed against a tree. A rodent may have crossed the path. Fruit may have fallen and begun to ferment nearby. Rain may have weakened an old scent trail but not erased it completely. To the musk cat, these traces form a map. This chemical map helps the animal find food, avoid danger, recognize territory, and locate possible mates. Scent markings can remain after the animal that created them has left, making them especially useful for solitary species. Hearing adds another layer. The civet's rounded ears are sensitive to soft sounds. It may detect the scratching of a beetle beneath dry leaves, the rustle of a lizard on bark, or the quick movement of a small mammal in grass. Because many of its prey animals are also active at night, silence becomes a competition. The prey tries not to be heard. The civet tries to hear what is almost silent. Its ears can adjust toward a sound, helping the brain compare the tiny difference in timing and loudness between one ear and the other. This allows the animal to estimate direction. A faint noise to the left causes the head to turn. Another sound follows. The civet pauses, listens again, and decides whether to continue. This patience is important. A successful nighttime hunter does not rush toward every sound. Wind moves leaves. Water drops from branches. Small animals create false signals. The civet must separate useful information from background noise. Its whiskers are another powerful sensory system. Long, sensitive hairs around the muzzle respond to touch and air movement. In darkness, whiskers help the musk cat judge narrow spaces, detect nearby surfaces, and position its head accurately. When moving through dense vegetation, the civet may not need to see every twig. Its whiskers can warn it that an opening is too small or that an object is close to its face. Similar sensory hairs may also be found around other parts of the body, helping the animal understand its immediate surroundings. The paws contribute information as well. Each careful step sends signals through the skin, muscles, and joints. The civet can feel whether a branch is rough, flexible, wet, or unstable. Claws help grip bark, while the muscles of the legs constantly adjust balance. The brain processes these signals rapidly, allowing the animal to move through complex terrain with remarkable control. Watching a musk cat climb can look almost effortless, but each movement requires constant calculation. The branch may bend under its weight. A surface may be slippery after rain. Leaves may hide an empty space. The civet shifts its center of gravity, lowers its body, and uses its tail as a counterbalance. If the branch moves, the animal responds almost instantly. The long tail is not usually fully prehensile in the Asian palm civet, meaning it cannot grip branches like the tail of some monkeys. But it still plays a major role in balance. When the civet turns, climbs, or crosses a narrow branch, the tail moves in the opposite direction to stabilize the body. This is similar to the way a tightrope walker uses a long pole. The civet's brain combines all these senses into one continuous picture. Vision shows shapes and movement. Smell reveals identity and history. Hearing detects hidden activity. Whiskers measure nearby spaces. Paws and muscles report balance and texture. The animal does not experience these senses separately. They work together. A faint fruit smell may cause the civet to change direction. It then sees a dark shape above. Its ears detect insects buzzing nearby. Its paws feel the bark as it begins to climb. At the fruiting branch, it touches the fruit with its nose, smells it closely, and may taste it before deciding whether to eat. Ripe fruit offers concentrated energy. Sugars provide fuel for long nighttime journeys. The civet may bite through soft skin and swallow pulp, seeds, and juice. If the fruit is unripe, bitter, or damaged, it may reject it. This ability to choose food carefully is one reason civets have become linked with coffee. A wild palm civet often selects ripe coffee cherries, probably using smell, taste, and texture. But coffee is only a small part of its natural diet. In the forest, food choices are far more diverse. The civet may interrupt its fruit meal when it hears movement below. Its body becomes still. The ears turn. The nose lifts. Perhaps it is a frog, a rat, a snake, or something larger. Stillness is one of the civet's best defensive behaviors. Movement attracts attention. By freezing, the animal becomes harder to detect. Its coat blends with bark and shadow. If the sound suggests danger, the civet may retreat higher into the tree, move quietly into thick leaves, or climb down and disappear through the undergrowth. Its senses are not only used to find prey. They are also used to avoid becoming prey. Large snakes can attack from branches. Birds of prey may hunt at dusk or dawn. Leopards and other predators can follow scent or movement. Humans and domestic dogs may also threaten civets near villages. For a small nocturnal mammal, survival depends on recognizing danger early. The forest at night is therefore not peaceful in the simple sense. It is calm, but active. Every creature listens, searches, hides, and responds. The civet moves through this world as both hunter and potential prey. Rain makes its sensory task even more complex. Water changes scent trails, softens sounds, and makes branches slippery. Heavy rain may reduce activity for a time, but light rain can also help the civet move quietly. Wet leaves do not crack as loudly as dry ones. Cooler air may carry scents differently. Weather influences where the animal searches and how far it travels. On some nights, food is easy to find. On others, the civet must explore a larger area. It often follows familiar routes. Memory helps it remember safe trees, fruiting plants, water sources, resting places, and dangerous zones. A civet may revisit a tree when its fruit is likely to ripen or avoid an area where it previously encountered a predator. This suggests that its nighttime life is not guided by instinct alone. Learning matters. Young civets gradually develop these skills. They must learn how to climb, which foods are safe, where to hide, and how to interpret smells and sounds. Early mistakes can be dangerous, so the period spent with the mother is important. Over time, the young animal builds its own mental map of the environment. That map is invisible, but incredibly detailed. It includes not only places but also timing. Certain flowers open at night. Some fruit falls at particular stages of ripeness. Insects appear after rain. Rodents become active at certain hours. Human activity may decrease late at night and increase before dawn. The musk cat learns the rhythm of its territory. As the night continues, it may travel from tree to tree, cross the ground, investigate a stream, and pause near a scent marking site. Its path may seem random, but each turn may have a reason. Then the eastern sky begins to brighten. Birds call again. Human voices return. The civet's nighttime advantage starts to fade. It searches for a safe resting place, curls its body, and wraps its tail nearby. The world of scent and shadow remains outside, but the animal becomes still. For us, dawn marks the beginning of activity. For the musk cat, it marks the end of a long, information-rich journey. In the next part, we will follow the civet's search for food and discover how a creature classified among carnivores became one of the forest's most important fruit eaters and seed dispersers. The forest gardener with a taste for fruit. There is something unexpectedly gentle about the way a musk cat searches for food. It does not crash through the forest like a large predator or tear at the ground with great force. Instead, it moves carefully, pausing beneath branches, lifting its nose, and testing the air for the scent of something ripe. Although civets belong to the order Carnivora, many species eat a surprising amount of fruit. Their bodies still carry the teeth and digestive features of meat-eating ancestors, yet their daily diet may include figs, berries, mangoes, palm fruits, bananas, coffee cherries, and many other soft tropical foods. This makes the musk cat one of nature's quiet opportunists. If fruit is abundant, it will eat fruit. If insects are easier to find, it will hunt insects. If a small reptile, frog, egg, or rodent appears nearby, it may take advantage of that opportunity as well. This flexible menu allows the animal to survive in places where food changes from season to season. In a tropical forest, ripeness is not evenly distributed. One tree may be covered in fruit while another nearby has none. Some fruits become available only for a few weeks. Others ripen slowly, one by one. The civet must remember where food has appeared before and recognize when it is worth returning. Its strong sense of smell helps with this task. A ripe fruit releases a complex mixture of chemicals into the air. As the fruit softens, its scent becomes stronger. Sugars increase, acids may decrease, and the surface begins to change. To a musk cat, these differences may be clear long before a human would notice them. The civet may climb toward the smell, reach the fruiting branch, and examine several fruits before choosing one. It touches them with its nose, bites gently, and sometimes rejects those that are still hard or bitter. This careful selection has made the Asian palm civet famous in the world of coffee. Coffee plants produce small fruits known as cherries. Inside each cherry are the seeds we call coffee beans. Wild palm civets may eat the ripest cherries and digest the sweet outer pulp. The beans pass through the digestive system and are later deposited in the animal's droppings. People began collecting these beans, cleaning them, drying them, and roasting them. The resulting coffee became known as kopi luwak. Its reputation spread around the world. It was described as rare, unusual, and luxurious. Some people believed that digestion inside the civet changed the beans and softened certain flavors. But the true story is more complicated than the elegant image often used in advertising. In the wild, coffee cherries are only one item in a varied diet. A free civet may eat a few ripe cherries, then move on to insects, figs, or other fruit. It chooses naturally and travels across a large area. Commercial demand changed this relationship. In some farms, civets have been captured and confined in small cages. Instead of selecting food freely, they may be given large quantities of coffee cherries. A diet that lacks variety can harm their health, while captivity can cause stress, repetitive behavior, injuries, and fear. For this reason, the most important question is not simply whether kopi luwak is rare. It is how it was produced. A product described as wild collected may be more ethical than one made from caged animals, but such claims can be difficult to verify. The animal's welfare is often hidden from the final buyer, far away from the forest where the story began. The civet itself receives no benefit from the high price of the coffee. In its natural environment, the animal's fruit-eating behavior has a far more valuable ecological role. It helps move seeds. When the musk cat swallows a fruit, Some seeds survive the journey through its digestive system. The animal may travel hundreds of meters or more before the seeds leave its body. This carries them away from the parent plant. That distance can be extremely important. Seeds that fall directly beneath their parent tree must compete for light, water, and nutrients. They may also face insects and diseases concentrated around that species. A seed carried to a new location has a chance to grow in a less crowded place. In this way, the civet becomes a seed disperser. It does not plant trees deliberately, but its nightly movements help forests renew themselves. A civet eating fruit in one part of the forest may unknowingly help create new vegetation somewhere else. The droppings surrounding the seeds may even provide a small amount of organic material, although survival still depends on soil, moisture, sunlight, and many other factors. Different fruits have different strategies for attracting animals. Bright colors may appeal to daytime birds and primates. Strong scents are especially useful for nocturnal mammals. A fruit that becomes fragrant after sunset may be announcing its readiness to creatures like bats and civets. This relationship benefits both sides. The civet receives energy, vitamins, and water from the fruit. The plant receives transportation for its seeds. Over long periods of evolution, such relationships can shape both animal behavior and plant characteristics. Fruits that are easier for animals to detect may have a greater chance of being eaten and dispersed. Animals that become skilled at locating nutritious fruit may survive and reproduce more successfully. The musk cat is therefore connected to the forest in ways that are not immediately visible. It may influence which seeds reach open spaces, riverbanks, forest edges, or abandoned land. It may help some plant species expand into new areas. It can also connect fragments of habitat by carrying seeds between them. Scientists study these relationships by examining droppings, identifying seeds, observing feeding behavior, and tracking animal movement. Camera traps can record civets visiting fruiting trees. GPS devices, when safely fitted by researchers, can reveal the routes they travel at night. These studies show that even a small, secretive mammal can have a large ecological effect. The musk cat is also a predator of insects and small animals. By eating beetles, rodents, frogs, and other creatures, it may influence local populations. Its role changes depending on location and season. During periods of abundant fruit, it may act mainly as a seed disperser. At other times, it may become more predatory. This shifting role makes it difficult to place the civet into one simple category. It is a hunter, a scavenger, a fruit eater, and a forest gardener. Near human settlements, this flexible diet can create conflict. Civets may enter orchards, poultry areas, roofs, or kitchens. They may take fruit that people intended to harvest or search through food waste. To the civet, this is not misbehavior. It is simply another feeding opportunity. Human environments often contain concentrated food sources. A fruit tree beside a house may produce more food in one place than many wild plants scattered through the forest. Rubbish bins may contain leftovers with strong smells. Roof spaces can offer warm, protected shelters. The same intelligence that helps a civet survive in the wild can help it adapt to towns. But living near humans also brings danger. Animals may be trapped, poisoned, chased by dogs, hit by vehicles, or captured for trade. They may be blamed for damage without anyone considering ways to reduce conflict safely. Simple measures can help. Food waste can be secured. Openings in roofs can be repaired after animals have safely left. Fruit can be collected promptly. Domestic animals can be protected at night. Coexistence begins with understanding. The musk cat is not searching for trouble. It is following scent, memory, and hunger through a changing landscape. As night deepens, it climbs into another fruiting tree. The branches sway gently beneath its weight. It chooses one soft fruit, settles into a stable position, and begins to eat. Far below, seeds from an earlier meal are already resting in the soil. Perhaps most will never grow, but one may survive the rain, insects, and shade. A root may push downward. A small stem may rise toward the light. Years later, that seed may become a tree, and no one watching the tree will know that its journey began inside a quiet animal moving through the darkness. In the next part, we will explore the musk cat's powerful scent glands and discover how a private chemical language became connected with some of the world's most expensive perfumes. The secret scent behind luxury perfume. For centuries, one of the most valuable ingredients in perfume did not come from a flower, a tree, or a rare spice. It came from a small nocturnal animal moving quietly through the forests of Africa and Asia. That animal was the civet, often called the musk cat. Near the base of its tail, the civet has special scent glands that produce a strong-smelling substance. In the wild, this scent is not created for humans. It is part of the animal's private communication system. A civet may leave scent on rocks, branches, pathways, or tree trunks, creating chemical messages for other members of its species. To another civet, these marks may reveal who passed through the area, how recently it happened, and whether the animal was male or female. The scent can help define territory, locate potential mates, and reduce unnecessary encounters. In darkness, this form of communication is extremely useful. A sound disappears as soon as it ends. A visual signal cannot be seen behind thick vegetation, but scent remains. It can survive for hours or even days, depending on weather, temperature, and the surface where it was placed. The civet's message is therefore a little like a note left in the forest. Humans discovered this scent long ago and gave the aromatic material the name civet. In concentrated form, natural civet has an intense odor that many people describe as animal-like, sharp, warm, or unpleasant. It does not smell like a finished perfume. But perfumers learned something surprising. When civet was used in extremely small quantities and mixed with flowers, woods, resins, and spices, its character changed. It could add warmth, depth, and softness. It could make floral notes seem richer and help a fragrance remain noticeable on the skin for a longer time. This is one of the strange arts of perfumery. An ingredient that smells harsh by itself may become beautiful when diluted and combined with others. For hundreds of years, natural civet was valued in parts of Africa, the Middle East, Asia, and Europe. It appeared in traditional medicines, incense, cosmetics, and fine fragrances. Because it was rare and difficult to obtain, it became associated with luxury. Royal courts and wealthy households sought complex perfumes made from ingredients gathered across long trade routes. Rose, jasmine, ambergris, sandalwood, musk, spices, and civet were blended into scents meant to suggest status, mystery, and refinement. The word musk cat added to this image, although civet and true musk are not the same thing. True musk historically came from the musk deer, while civet came from civets. Both were animal-derived fragrance materials, but they had different chemical compositions and different histories. Over time, everyday language sometimes mixed these ideas together. This confusion still exists today. The animal called the musk cat is not a source of true deer musk. Its famous fragrance material is civet paste, produced by its own glands. In the wild, the civet releases only the amount needed for its natural behavior. Traditional commercial collection, however, often involved keeping animals in captivity. The substance could be scraped or collected repeatedly from the glandular area. This process created serious welfare problems. Civets are solitary, active animals that naturally travel, climb, explore, and search for varied foods. In captivity, some were confined to small cages with little space or stimulation. Repeated handling and extraction could cause stress, pain, fear, and injury. The perfume itself might have seemed elegant and luxurious, but the reality behind the ingredient could be harsh. As awareness of animal welfare grew, the fragrance industry began moving away from natural civet. Chemists identified important odor molecules found in the secretion and developed synthetic versions that could reproduce similar effects. One of the best-known compounds associated with civet odor is civetone. Civetone is a large ring-shaped molecule with a powerful scent. In small concentrations, it can produce a warm, musky, animalic character. Synthetic civetone and other related fragrance materials allow perfumers to create depth without relying on secretions taken from captive animals. This development transformed modern perfumery. Today, most large fragrance companies use synthetic alternatives rather than natural civet. These materials are more consistent, easier to control, and generally more ethical. They can also be produced without the variations that occur naturally between animals, seasons, diets, and collection methods. Yet the story of civet remains important because it reveals how perfume works. A fragrance is not simply one pleasant smell. It is a structure made from many materials that appear, change, and fade at different speeds. The first scents noticed after spraying are called top notes. These may be bright, fresh, citrus-like, or herbal. They evaporate quickly. The middle, or heart notes, appear more slowly. They often include flowers, spices, fruits, or aromatic plants. Base notes remain the longest. Woods, resins, vanilla-like materials, amber accords, and musky ingredients often belong to this deeper layer. Historically, civet was mainly used as a base note and fixative. It could support other ingredients and make the perfume feel warmer and more complete. A perfumer might use only a tiny trace. Too much civet could overwhelm the entire composition. The skill was to add so little that the wearer might never identify it directly. Instead, the fragrance would simply seem richer, smoother, or more alive. This idea is similar to adding a small amount of salt to sweet food. The salt is not meant to become the main flavor. It changes how everything else is perceived. Animalic notes have often been used to make perfumes feel less clean and more human. Flowers in nature are not always perfectly soft or pure. They may contain green, earthy, spicy, indolic, or even slightly decaying scents. A trace of civet could make a floral perfume seem warmer, darker, and more natural. Jasmine is a famous example. Its scent includes molecules that can feel sweet and floral at low levels but more intense and animalic at higher concentrations. When paired carefully with musky materials, jasmine can seem almost luminous. This is why old perfumes may smell very different from modern ones. Many historic formulas used ingredients that are now restricted, replaced, or considered unethical. Changes in law, conservation, public taste, chemistry, and manufacturing have transformed the industry. Modern perfumers can create an animalic effect with combinations of synthetic musks, leather-like notes, amber materials, woods, and laboratory-made aroma molecules. They are no longer limited to substances collected from living animals. However, the word civet may still appear in descriptions of a perfume. This does not always mean the fragrance contains natural civet. It may refer to an accord, which is a carefully designed combination of ingredients that creates the impression of civet. An accord is like a musical chord. No single ingredient produces the complete effect. Several notes work together to create an illusion. This matters for consumers who want cruelty-free products. A perfume described as animalic, musky, or civet-like may still be made entirely from synthetic and plant-based materials. The safest approach is to check the manufacturer's animal welfare policies and ingredient information, although perfume formulas are often protected as trade secrets. The civet's natural scent has also interested scientists. Chemical communication is one of the oldest forms of information exchange in the animal world. By studying scent secretions, researchers can learn about reproduction, territory, behavior, and species recognition. The same substance that humans once valued for perfume may contain a complex mixture of chemicals carrying biological information. A civet does not experience its scent as a luxury ingredient. It experiences it as part of identity. This contrast is remarkable. For the animal, scent means territory, communication, and survival. For humans, it became fashion, wealth, desire, and art. The distance between those two meanings is enormous. It also reminds us that human culture often takes materials from nature and gives them entirely new purposes. A secretion used on a tree trunk becomes a perfume ingredient. A fruit eaten in the forest becomes an expensive coffee. A secretive animal becomes a symbol of luxury. But behind every product is a living creature with its own needs. The civet must sleep, search for food, avoid predators, raise young, and navigate its territory. Its glands are not factories. They are part of a sensitive biological system. Understanding this changes the story. The most beautiful modern fragrances do not need to depend on animal suffering. Chemistry can recreate warmth, depth, and sensuality without confining civets or repeatedly collecting natural secretions. In this way, science has not removed the mystery of perfume. It has given perfumers new tools to create that mystery more responsibly. Imagine a civet moving through a wet forest after rain. It pauses beside a tree, leaves a scent mark, and disappears into the leaves. Hours later, another civet may find that mark and understand something about the stranger who passed. Thousands of kilometers away, a perfumer may create a similar aromatic impression using molecules produced in a laboratory. The two worlds are connected by scent, but their purposes are completely different. One belongs to the silent language of animals. The other belongs to human imagination. In the next part, we will explore the musk cat's hidden daily life, where it sleeps, how far it travels, and why its quiet routine is far more complex than it first appears. The hidden routine of a nocturnal life. When we imagine a wild animal, we often picture dramatic moments: a chase, a fight, a sudden escape, or the discovery of food. But most of life is made of quieter things: resting, listening, choosing a path, returning to a familiar place, avoiding danger before it appears. The daily life of a musk cat is built from these small decisions. During daylight, the civet usually remains hidden. It may curl up inside a hollow tree, rest among thick branches, shelter beneath dense vegetation, or sleep in a quiet space beneath a roof. The exact resting place depends on the species, the landscape, the weather, and the presence of predators. A safe sleeping site must offer more than darkness. It should be difficult to reach, protected from rain, and hidden from animals that might attack. It may also need to be close enough to food that the civet does not waste too much energy traveling when night begins. For an animal that lives alone, choosing the right shelter is an important part of survival. Some civets use the same resting place repeatedly. Others maintain several possible shelters and move between them. This flexibility is useful because a location that feels safe one week may become dangerous the next. A snake may discover the hollow. A human may cut down the tree. A rival animal may begin using the area. Heavy rain may flood a ground-level shelter. The civet must constantly evaluate its surroundings. Even while resting, it is not completely unaware. Its ears remain sensitive to unfamiliar sounds. A sudden vibration or smell may cause it to wake quickly. Deep sleep can be dangerous in the wild, especially for a small animal that may be hunted by larger predators. The civet often sleeps curled into a compact shape. This posture conserves warmth and protects vulnerable parts of the body. The long tail may lie along the side or wrap partly around the body. In hot climates, however, the animal may stretch out to release heat. Tropical nights can be warm and humid, and temperature influences how active the civet becomes. As evening approaches, subtle changes begin. The air cools. Daytime sounds fade. Insects emerge. Fruit scents become stronger in the moist air. The civet lifts its head, stretches its body, and begins to groom. Grooming is not simply about cleanliness. By licking its fur, the animal removes dirt, parasites, loose hair, and unwanted odors. It may also help maintain the insulating quality of the coat. A healthy coat protects the skin and reduces the risk of irritation. Grooming may take only a few minutes, but it prepares the civet for hours of movement. When darkness becomes deep enough, the animal leaves its shelter. At first, it may move slowly. It pauses, smells the air, and listens. Before beginning a longer journey, it needs to know whether the area is safe. A civet does not wander randomly. It usually has a home range, an area in which it searches for food, rests, marks scent, and encounters other animals. The size of this range can vary greatly. Food availability, habitat quality, sex, age, and population density all influence how far an individual travels. Where fruit and prey are abundant, a civet may not need to move far. In a damaged or dry habitat, it may travel much greater distances. A home range is not always defended like a fortress. The ranges of different civets may overlap, especially where food is plentiful. But animals may still avoid direct contact by using scent marks and visiting the same places at different times. This creates a quiet form of separation. Two civets may walk along the same fallen tree on the same night without meeting. One passes before midnight. The other arrives hours later and reads the scent left behind. Scent allows them to share a landscape while reducing conflict. The civet may begin its journey by following a familiar route. Animals often create mental maps of their environment. A path through vegetation, a low wall, a line of trees, or a stream bank can become part of a regular circuit. Familiar routes save energy and reduce risk. The civet already knows where branches are stable, where dogs may appear, where water collects, and where fruit has been found before. It can travel more confidently through known territory than through an unfamiliar place. But routine does not mean the same path is followed every night. Food changes constantly. A fruiting tree may be empty. A storm may break a branch. Human activity may block a route. The civet adjusts, combining memory with fresh information. This ability to adapt is one reason some civets survive near farms and cities. A night's activity may be divided into several periods. The civet may travel, stop to eat, rest briefly, groom, investigate scent marks, and then continue. It does not necessarily move continuously from sunset to sunrise. Energy must be managed carefully. Climbing uses strength. Hunting requires concentration. Crossing open ground increases danger. Resting at the right moment can be as important as moving. The civet may sit on a broad branch for several minutes, almost motionless. To a person watching, it may appear to be doing nothing. In reality, it may be listening, digesting food, waiting for danger to pass, or deciding where to go next. Much of animal behavior is invisible unless we understand the reasons behind stillness. Water is another part of the nightly routine. Civets obtain some moisture from fruit, but they may also drink from streams, puddles, tree holes, or containers near human homes. A reliable water source can influence the shape of the home range. Approaching water can be risky because many animals gather there. The civet pauses before drinking. It looks around, smells the edge, and listens. Only when the area seems safe does it lower its head. Even then, it may raise its face repeatedly between sips. This pattern reflects the constant balance between hunger, thirst, and caution. Near villages, the civet's routine may include rooftops, gardens, fruit trees, and quiet alleys. Buildings can function like artificial cliffs or hollow trees. Roof spaces provide shelter. Walls create elevated paths. Electrical wires or branches may connect one structure to another. At night, a civet can move through a town almost unseen. Its presence may be noticed only through sounds above the ceiling, droppings, fruit remains, or a brief glimpse in a flashlight beam. People sometimes assume that an animal living near houses has lost its wild nature. But adaptation to human environments does not mean domestication. The civet still follows its instincts. It remains cautious, territorial, and capable of defending itself. It may also face new problems. Artificial lighting can disturb natural activity. Traffic creates deadly barriers. Waste may provide easy food but also expose animals to plastic, chemicals, and unhealthy diets. Domestic dogs can chase or kill them. The modern landscape offers opportunity and danger at the same time. Scientists study civet routines with several methods. Camera traps are placed along animal paths and activated by movement. They record the time, direction, and frequency of visits. Over many weeks, researchers can begin to see patterns. Some civets appear soon after sunset. Others are most active in the middle of the night. Activity may change with the moon, rainfall, temperature, or human disturbance. Radio collars and GPS trackers can reveal even more. A lightweight device, fitted under controlled conditions, records the animal's location. Researchers can then map its movements, resting areas, feeding sites, and road crossings. These maps often reveal a life far more organized than people expect. The civet may return repeatedly to the same trees. It may use narrow strips of vegetation to move between forest fragments. It may avoid open fields or cross them only at the darkest hours. This information is valuable for conservation. If scientists know where animals travel, they can identify important habitat corridors. A small line of trees beside a river may be the only safe route between two forests. Removing it could isolate populations. Protecting wildlife is not always about preserving enormous untouched areas. Sometimes, a narrow connection makes the difference between movement and isolation. The civet's routine also changes with the seasons. During a rich fruiting period, it may spend more time in trees. When insects become abundant after rain, it may search the forest floor. During dry periods, water sources become more important. Breeding changes behavior as well. An animal that is usually solitary may search more widely for a mate. A mother caring for young may remain closer to a safe den and make shorter feeding trips. Her schedule becomes shaped by the needs of the offspring. Young civets begin life completely dependent. As they grow, they observe, explore, and slowly learn the routes of the night. They practice climbing, test unfamiliar foods, and develop the coordination needed to move safely. The mother does not teach with words, but her behavior becomes a model. She chooses paths, reacts to danger, and leads the young toward food. Through experience, they begin to build their own routines. Eventually, they must leave and establish lives of their own. By the final hours before dawn, the adult civet has often completed a long circuit. It may have eaten fruit, hunted insects, visited water, investigated scent marks, and crossed several different habitats. Now it must return to safety. As the sky becomes pale, the forest changes again. Birds wake. Human movement increases. The civet becomes more exposed. It chooses a resting place, enters quietly, and settles down. To us, the night may have seemed calm and empty. For the musk cat, it was filled with decisions. Where to climb, what to eat, when to stop, which scent to follow, which sound to avoid, which route will lead home. Its routine is not dramatic, but it is precise. And behind that quiet precision is a mind constantly reading the world. In the next part, we will enter the private life of the musk cat and discover how civets find mates, raise their young, and prepare the next generation for survival in the darkness. Birth, motherhood, and the first lessons of the night. Every musk cat begins life in complete dependence. Before it becomes a silent hunter, a careful climber, or a traveler of moonlit branches, it is a small and vulnerable newborn hidden inside a protected den. Its eyes are closed, its movements are weak, and the world beyond its mother is still unknown. The private family life of civets is difficult to observe because these animals are secretive, mostly nocturnal, and often active in dense vegetation. Much of what scientists know comes from field observations, camera traps, captive studies, and careful examination of nesting sites. Different civet species have different breeding patterns, but many share the same basic strategy. Adults usually live alone, coming together mainly to mate. For most of the year, a male and female may travel through overlapping areas without forming a permanent pair. Their first contact often begins through scent. A male can detect chemical information left by a female on branches, stones, tree trunks, or the ground. These scent marks may indicate that she is nearby and ready to reproduce. The male may then follow the trail, moving through the night with unusual attention. Finding a mate is not always simple. The female may reject the first approach. She may hiss, growl, move away, or defend her space. Courtship can involve repeated following, scent investigation, short vocalizations, and cautious physical contact. To humans, this behavior may appear tense, but caution is understandable. Civets have sharp teeth and claws, and an unwanted close encounter can lead to injury. Eventually, if the female accepts the male, mating occurs. Afterward, the adults usually separate and return to their solitary lives. In many species, the mother raises the young alone. This means she must choose a den carefully. The place must protect newborns from predators, rain, heat, cold, and disturbance. A hollow tree is ideal for some civets. Others may use dense vegetation, rocky cavities, abandoned burrows, or hidden spaces inside buildings. A den near food is especially valuable because the mother cannot leave her young alone for too long. Pregnancy length varies among species, but after a relatively short gestation, the female gives birth to a small litter. The number of young can differ, though litters of several offspring are common in some civets. The newborns are tiny compared with the adult. Their bodies may already have soft fur, but they cannot yet survive without warmth and milk. Their eyes and ears are not fully functional at first, and their movements are uncoordinated. The mother spends much of her time close to them. She curls around the young to provide warmth. She cleans them with her tongue and responds to their soft calls. Her body becomes their first shelter, food source, and protection. Milk contains the energy and nutrients required for rapid growth. During the first stage of life, the young depend entirely on it. The mother must also care for herself. She needs enough food and water to produce milk, maintain her health, and remain alert. This creates a difficult balance. Every journey away from the den is necessary, but every absence carries risk. Before leaving, she may listen carefully and inspect the area. Then she slips into the darkness to search for fruit, insects, small animals, or other foods. Her feeding trips may be shorter than usual. A civet without young can travel widely and spend long periods investigating food sources. A nursing mother may remain much closer to the den. She must return before the newborns become too cold, hungry, or vulnerable. Predators are not the only danger. Ants, parasites, flooding, falling branches, and sudden human disturbance can threaten a den. If the mother senses that the shelter is no longer safe, she may move the litter. Transporting young is demanding. Depending on the species and age of the offspring, she may carry them gently in her mouth, one at a time, to a new location. She must repeat the journey until the entire litter is secure. Each trip exposes her and the young to danger, so the new den must be worth the risk. As the days pass, the young begin to change quickly. Their eyes open. Their hearing improves. Their legs grow stronger. At first, the den is their entire universe. They crawl over one another, sleep beside the mother, and react to unfamiliar sounds. Soon, curiosity begins to pull them outward. A young civet may approach the den entrance and stare into the darkness. The forest beyond is filled with smells and noises it has never experienced. At this stage, the mother's presence is essential. She may block an unsafe movement or call the young back with a sound. She may tolerate their clumsy climbing attempts while remaining close enough to catch or guide them. The first steps outside the den are uncertain. The young place their paws awkwardly. A branch that feels stable to an adult may move unexpectedly beneath a smaller animal. Balance must be learned through practice. The tail begins to play a more important role. At first, the young may hold it stiffly or move it without control. Over time, it becomes part of the body's balancing system, shifting as the animal turns or climbs. Falling is a real danger, but practice cannot be avoided. A civet born for life in trees must learn the architecture of branches, which ones bend, which ones break, which surfaces become slippery after rain, and how far the body can safely stretch. The mother cannot explain these things. The young learn by watching, following, touching, slipping, correcting, and trying again. Food is another major lesson. At first, the young rely on milk. Later, the mother may bring food close to the den or lead them towards safe feeding places. They begin to taste soft fruit, insects, and small pieces of animal food. Not everything that smells interesting is safe. Some fruits are bitter or unripe. Some insects can sting. Some animals are dangerous to approach. Learning what to eat involves instinct, observation, and experience. The young may copy the mother's choices. If she eats a particular fruit, they may investigate it. If she reacts sharply to a smell or sound, they may learn caution. This kind of learning is subtle but powerful. The mother also introduces them to the language of scent. As they move through the environment, they encounter marks left by other civets. At first, these smells may have little meaning. Gradually, the young learn to distinguish familiar from unfamiliar signals. They begin to understand where the mother travels, where other animals have passed, and which areas may be occupied. Scent becomes part of their map of the world. Play may also contribute to development. Young civets may chase, pounce, climb over one another, or wrestle. These behaviors appear playful, but they help build strength, speed, coordination, and social awareness. A sudden leap at a sibling is practice for catching prey. A gentle bite teaches control. A chase along a branch improves balance and timing. In the safety of youth, important survival skills can be repeated without the full consequences of adult life. But safety is never complete. The mother remains watchful because young animals are easier targets for predators. Snakes may enter dens. Birds of prey may attack exposed juveniles. Larger carnivores may follow scent. When danger appears, the mother may produce warning calls, place herself between the young and the threat, or lead them toward cover. She may also remain motionless, relying on camouflage. The young must learn that silence can be a form of defense. A frightened animal that runs at the wrong moment may reveal its position. Sometimes the safest response is to freeze and let the forest become still again. As the young grow, their movements become more confident. They begin to accompany the mother on longer nighttime journeys. At first, they remain close behind her. Later, they explore a few meters away, returning when something frightens them. These trips are the beginning of independence. The young learn where water can be found, which trees produce fruit, where humans and dogs are active, and which paths provide shelter. They begin constructing their own mental maps. Memory becomes one of their most valuable tools. A civet that remembers a safe tree can escape more quickly. One that remembers where fruit ripens can save energy. One that remembers danger can avoid repeating a mistake. By the time the young are weaned, they can eat solid food, but they may still remain with the mother for a period while their skills develop. Independence is gradual rather than sudden. Eventually, however, the young must leave. Remaining together would create competition for food and shelter. Solitary adults need space, and growing juveniles must establish home ranges of their own. The moment of separation may not be dramatic. One night, a young civet follows a different scent or travels farther than before. It explores a new tree, finds food, and does not immediately return. Over time, the distance increases. The mother's territory becomes part of memory, while another area begins to feel familiar. This is one of the most dangerous stages of life. A young civet without an established range does not know every shelter, predator route, road, or feeding site. It may cross open land or enter the territory of an older animal. Experience must now be gained without protection. Some juveniles do not survive this period. Nature can be unforgiving, especially where habitat has been damaged or fragmented. Those that succeed become the next generation of nocturnal travelers. They begin scent marking their own routes. They discover resting places. They develop preferences for particular foods and learn the rhythms of the landscape. In time, they too may follow a scent through the darkness and begin the cycle again. The story of the musk cat's family life is quiet and mostly hidden, but it is filled with devotion, risk, and learning. A mother feeds, warms, carries, protects, and guides her young without ever being seen by most humans. The lessons she gives are not spoken. They are shown in the placement of a paw, the choice of a fruit, the pause before crossing open ground, and the sudden stillness that means danger is near. And when the young finally disappear into separate parts of the forest, they carry those lessons with them. In the next part, we will explore the dangers musk cats face, from natural predators and busy roads to captivity, hunting, and the rapidly changing forests of the modern world. The dangers waiting beyond the shadows. A musk cat may seem perfectly designed for the night. It can climb, hide, smell danger, remember safe routes, and move almost without sound. Yet even such a cautious animal lives in a world filled with risk. Some dangers are ancient. For millions of years, civets have shared their habitats with larger predators. Big cats, pythons, birds of prey, crocodiles, and other carnivores may all pose a threat, depending on the region and the species involved. A civet is both a hunter and potential prey. This double role shapes nearly everything it does. It pauses before crossing open ground. It avoids unnecessary noise. It chooses hidden resting places. It listens while drinking and freezes when it senses movement nearby. Survival depends not on being the strongest animal in the forest, but on detecting danger early enough to escape. Camouflage is the first defense. The muted colors of many civets blend into bark, leaves, soil, and shadow. Spots and stripes break up the outline of the body, making it harder for a predator to recognize a clear shape. This effect is especially useful in dim light. A predator may see movement but fail to determine exactly where the civet begins and the background ends. Even a few seconds of confusion can be enough for the smaller animal to disappear into vegetation. Stillness is another defense. When frightened, the civet may stop moving completely. Motion attracts attention, while a silent, motionless animal becomes part of the landscape. If hiding fails, escape becomes the next option. Tree-dwelling civets may climb upward, cross narrow branches, or move into dense foliage where larger predators cannot follow easily. Ground-dwelling species may rush toward thick cover, rocks, or hollow logs. Their long bodies allow them to squeeze into spaces that would be too small for a larger hunter. But escape is not always possible. A cornered civet can defend itself with sharp teeth and claws. It may hiss, growl, arch its body, and release a strong odor from its scent glands. The smell is not simply unpleasant. It can startle or confuse an attacker, buying the civet time to flee. This defense is similar in purpose to the spray of a skunk, although the animals and their chemical systems are different. For a predator, the cost of attacking matters. Even a small animal can injure an eye, nose, or paw. A predator that has safer food available may decide that a civet is not worth the risk. Natural dangers, however, are no longer the only challenges. Today, many civets face threats created by humans, and these threats can change the landscape faster than the animals can adapt. Habitat loss is one of the most serious. Tropical forests are cleared for timber, roads, farms, plantations, mines, and expanding cities. When large areas of forest disappear, civets lose food, shelter, and safe travel routes. A single civet may still survive in a small forest fragment, but long-term survival requires more than one hidden tree. Populations need connected habitats. When forests are divided into isolated patches, animals may be forced to cross open fields, roads, or settlements. These journeys expose them to vehicles, dogs, hunters, and conflict with people. Habitat fragmentation can also separate breeding populations. If animals cannot move safely between forest patches, genetic diversity may decline. Smaller isolated populations are more vulnerable to disease, local disasters, and inbreeding. A strip of trees beside a river or road may seem unimportant to humans, but it can function as a wildlife corridor. For a civet, such a corridor may be the only safe connection between two larger habitats. Roads are especially dangerous at night. Civets often travel after dark, the same time when drivers may have difficulty seeing small animals. Headlights can confuse or freeze wildlife. An animal that pauses in the road may be struck before it can escape. Road deaths can have a large effect on local populations, particularly where traffic passes through forests or plantations. Young civets are often at greater risk because they have less experience with vehicles and unfamiliar landscapes. Artificial light creates another subtle problem. Streetlights, houses, factories, and illuminated roads change the natural rhythm of darkness. Some animals avoid brightly lit areas, while others may be attracted by insects gathering around lamps. Either response can alter feeding behavior. A civet that avoids light may lose access to part of its territory. One that approaches lights may become more visible to humans, dogs, and vehicles. Noise can also interfere with the nighttime world. Engines, machinery, music, and construction may cover the faint sound civets use to detect prey and danger. An animal that cannot hear clearly must rely more heavily on sight and smell. This may increase stress and reduce hunting success. Food waste attracts many civets into towns. At first, rubbish can appear to be an easy food source. It is concentrated, predictable, and often rich in calories. But human waste can contain plastic, spoiled food, chemicals, sharp objects, and substances that are harmful to wildlife. Animals may become dependent on unreliable food sources. They may also lose some of their natural caution around people, increasing the chance of conflict. When civets enter roofs, gardens, orchards, or poultry areas, people may consider them pests. The animals can be trapped, poisoned, beaten, or killed. Yet many conflicts can be prevented without harming them. Securing rubbish, collecting fallen fruit, protecting poultry, and sealing building openings after the animal has left can reduce visits. The goal should be to remove the attraction rather than punish the animal for following food. Hunting is another major threat. Civets may be hunted for meat, traditional medicine, fur, perfume ingredients, or the wildlife trade. In some regions, hunting is opportunistic. In others, animals are captured systematically. Wire snares are particularly cruel. A snare does not choose its victim. It can trap civets, deer, primates, or endangered species. An animal caught by the leg, neck, or body may struggle for hours or days before dying from injury, dehydration, or predation. Even animals that escape can suffer permanent wounds. The live animal trade creates additional suffering. Civets may be sold as exotic pets, displayed for tourism, used in breeding operations, or confined for coffee production. The Asian palm civet has become especially vulnerable to exploitation because of its connection with kopi luwak. Images of a civet beside coffee cherries may appear natural and appealing. In reality, many commercially used animals are kept in cages. A wild civet would normally travel, climb, choose food, scent mark, rest in different locations, and avoid other civets. A cage removes nearly all of these behaviors. The animal may pace repeatedly, bite the bars, overgroom, remain unnaturally still, or show other signs of chronic stress. A coffee-only diet can also cause nutritional problems. Civets are omnivores. They require varied foods, not endless quantities of one fruit. Captivity can expose them to injury, disease, poor sanitation, and constant human contact. Claims such as wild, natural, or ethically produced are difficult to verify. A consumer may see only the finished package, not the conditions in which the animal lived. The perfume trade historically caused similar problems. Natural civet paste was repeatedly collected from captive animals. Today, synthetic alternatives have reduced demand, but illegal or traditional use may still continue in some places. The existence of a laboratory-made replacement does not automatically end exploitation. Laws, enforcement, education, and consumer choices all matter. Disease is another complicated issue. Wild civets can carry parasites and pathogens, as all wild mammals can. This does not mean they are naturally dangerous or should be feared. The greatest health risks often arise when animals are captured, crowded, transported, stressed, and kept near other species. Under these conditions, pathogens have more opportunities to spread. Wildlife markets and poorly managed farms can bring animals together that would rarely meet in nature. Stress weakens immune systems, while close contact increases transmission. Protecting wildlife health and human health are therefore connected. A healthy civet in a functioning forest is very different from a frightened animal confined in a crowded cage. Climate change may create additional pressure. Changes in rainfall, temperature, drought, and fruiting seasons can alter food availability. A plant that once produced fruit at a predictable time may shift its cycle. Streams may dry earlier. Fires may become more frequent. Strong storms may destroy nesting trees and fragment habitat. Because civets are adaptable, some may adjust better than highly specialized animals. But adaptability is not unlimited. An animal cannot survive without enough food, water, shelter, and safe space. Different civet species face different levels of danger. Some remain widespread and are currently considered relatively secure. Others have small populations, restricted ranges, or rapidly declining habitats. This is why the phrase musk cat can be misleading in conservation discussions. It describes several animals, and each one has its own story. A common species in one region should not make us assume that all civets are safe. Scientists assess populations through camera traps, field surveys, genetic samples, local reports, and records of hunting and trade. Because civets are nocturnal and secretive, counting them is difficult. An area may appear empty simply because the animals are rarely seen. On the other hand, occasional sightings near houses may create the impression that they are abundant, even while the wider population is declining. Good conservation requires careful evidence. Local communities play an important role. People living close to forests often understand animal behavior better than distant observers. They know where civets travel, which trees they visit, and when conflicts occur. Conservation is more successful when local knowledge, scientific research, and practical needs are combined. Protecting civets does not mean ignoring the problems they may cause. Farmers need to protect fruit and poultry. Families need safe homes. Communities need roads and livelihoods. The challenge is to find solutions that reduce harm on both sides. Wildlife bridges, road signs, speed limits, protected forest corridors, secure waste containers, and humane conflict management can all help. Consumer choices matter as well. Avoiding products linked to caged civets reduces financial support for harmful practices. Choosing synthetic, cruelty-free fragrance materials helps move the perfume industry away from animal exploitation. Asking questions about kopi luwak may be more important than paying for rarity. Where did it come from? Were the animals wild? Can the claim be independently verified? Sometimes the most responsible choice is not to buy the product at all. The future of the musk cat will depend partly on whether humans see it as more than a source of coffee, perfume, meat, or entertainment. It is a living part of the ecosystem. It disperses seeds, controls some animal populations, feeds larger predators, and responds to environmental change. Its presence can tell us something about the health of the landscape. As the civet steps from the forest onto a roadside, it carries no understanding of borders, laws, markets, or luxury brands. It only knows the familiar scent of fruit ahead. The trees have become fewer. The road is bright. A vehicle approaches in the distance. The animal pauses. This single moment contains the whole challenge of modern wildlife survival, an ancient creature trying to navigate a world transformed almost overnight. In the next part, we will explore the surprising intelligence of the musk cat, how it remembers routes, solves problems, adapts to human environments, and makes careful decisions in the darkness. The quiet intelligence of the musk cat. A musk cat does not need to solve puzzles in a laboratory to prove that it is intelligent. Its intelligence can be seen in the way it remembers a hidden fruit tree, avoids a dangerous road, opens a weakly secured container, or changes its route after a single frightening experience. For a nocturnal animal, intelligence is not about showing off. It is about survival. Every night, the civet must make dozens of decisions. Should it climb higher or remain on the ground? Is that sound made by prey, wind, or a predator? Is a familiar path still safe? Is the fruit ripe enough to eat? Has another civet recently entered the area? These decisions happen quietly and quickly. The musk cat's brain receives information from smell, hearing, vision, touch, and memory. It compares what is happening now with what happened before. Then it chooses a response. This ability to combine experience with current information is one of the foundations of animal intelligence. Memory is especially important. A civet may travel through a large home range containing many trees, streams, hiding places, roads, buildings, and feeding sites. It cannot inspect every location each night. That would waste too much time and energy. Instead, it remembers. A tree that produced ripe fruit several nights ago may be worth checking again. A garden where dogs appeared may be avoided. A roof opening that led to a safe shelter may become part of a regular route. These memories form a mental map. The map is not drawn in lines or symbols, but it may still be highly detailed. It includes distance, direction, smell, texture, and timing. The civet may remember that a certain branch leads toward a fruiting palm, that a stream becomes difficult to cross after heavy rain, or that human activity decreases after midnight. Time matters almost as much as place. A feeding site that is dangerous at dusk may be safe later. A rubbish area may contain food only after people leave. A fruit tree may attract birds during the day and civets at night. The musk cat learns not only where to go, but when to go there. This ability is valuable in towns and villages. Human environments change rapidly. Doors open and close. Lights switch on. Vehicles pass. Food waste appears at regular times. Domestic animals are released into gardens. A civet living near people must study these patterns. Some individuals become remarkably skilled at using buildings. They may climb walls, walk along fences, enter roof spaces, or cross between trees and houses. To a civet, a town is not completely unnatural. Walls can resemble cliffs. Roof beams can function like branches. Drainage channels can become pathways. Gardens may contain fruit, insects, water, and shelter. The animal interprets human structures through the abilities it already possesses. This is an important point about adaptation. The civet does not need to understand what a house is for. It only needs to recognize that a narrow opening provides shelter or that a wall offers a safe elevated route. Its intelligence is practical. Researchers sometimes describe this kind of ability as behavioral flexibility. An animal shows flexibility when it changes its behavior in response to new conditions rather than repeating the same action automatically. Civets often display this quality. If one path becomes blocked, they may search for another. If food disappears from a familiar location, they expand their search. If a trap or threat appears, they may become more cautious around similar objects. Learning from experience can happen very quickly. A single frightening encounter with a dog may cause a civet to avoid that garden for days or weeks. A safe food source may encourage repeated visits. This is called associative learning. The animal connects one event with another. A particular smell may become associated with food. A sound may signal danger. A light may predict human activity. Over time, these connections shape behavior. The musk cat can also learn by observing. Young civets follow their mother and watch what she eats, where she climbs, and how she reacts to danger. They may not copy every action exactly, but her behavior provides valuable information. Social learning reduces risk. Instead of discovering every danger through direct experience, a young animal can respond to the mother's alarm or hesitation. Even adults may gather information indirectly. The scent of another civet near a new food source may attract attention. The alarm calls of birds may signal that a predator is present. The sudden silence of insects may indicate movement nearby. The forest is full of information created by other animals. An intelligent civet does not rely only on its own senses. It also notices the reactions of the surrounding community. Problem solving becomes especially visible when civets search for food. A fruit protected by leaves may require careful climbing. An insect hidden under bark may need to be scratched out. An egg inside a nest may be reached from an unusual angle. Near humans, the challenges can become more complex. A civet may push against a loose lid, squeeze through a gap, climb a pipe, or move an object blocking access to food. These actions do not always mean the animal understands the full mechanics of the problem. Sometimes trial and error is enough. It tries one movement. If the result is useful, it repeats it. Success strengthens the behavior. This is how many animals learn to open containers or enter buildings. One accidental discovery can become part of a regular routine. Civets also show strong curiosity. Curiosity encourages investigation of new smells, objects, and places. This can lead to food and shelter, but it can also create danger. A civet may approach a camera trap, sniff a bag, or examine a new structure. It may touch the object with its nose or paw before deciding whether to continue. Curiosity is useful in changing environments because it helps animals discover opportunities. But excessive curiosity can lead to traps, poison, traffic, or capture. Successful animals balance curiosity with caution. The musk cat appears to do this carefully. It often approaches unfamiliar objects in stages. First, it watches from a distance. Then it moves closer, pauses, smells, and perhaps circles the object. This gradual investigation reduces risk. The animal does not need to understand that an object is a human-made trap. It only needs to notice that something is unfamiliar and potentially dangerous. Individual personality also matters. Not every civet behaves in the same way. Some may be bold and willing to approach houses. Others remain deep in the forest. Some quickly investigate new objects. Others avoid them for long periods. Scientists refer to consistent differences like these as animal personalities. Bold individuals may find new food faster, but they may also face greater danger. Cautious individuals may avoid traps and people, but they could miss valuable opportunities. Neither strategy is always best. The environment determines which behavior succeeds. In a quiet forest, bold exploration may be useful. Near roads and hunters, caution may increase survival. This variety within a population is important because conditions can change. If every civet behaved in exactly the same way, one new threat could affect them all. Different personalities create different responses, increasing the chance that some individuals will survive. The civet's ability to navigate is another sign of intelligence. It may travel through darkness without seeing distant landmarks clearly. Smell, memory, branch structure, slopes, water flow, and the position of openings in the canopy may all help with orientation. Some mammals also use the position of the moon, stars, or polarized light, although the exact importance of these signals in civets is still not fully understood. What is clear is that they can return to familiar resting and feeding areas with impressive accuracy. A civet released from a temporary capture point may move directly toward known cover. An animal displaced over a short distance may attempt to return to its home range. This attachment to place suggests that its internal map is strong. The home range contains more than resources. It contains knowledge. An unfamiliar landscape is dangerous because the animal does not know where to hide, drink, climb, or escape. This is one reason relocation is not always a humane solution when civets enter houses. Moving the animal far away may seem kind, but it can place it in another civet's territory without knowledge of food or shelter. It may try to return and cross dangerous roads. Preventing access and reducing food attraction is often more effective than simply removing the animal. Understanding civet intelligence can improve coexistence. If a musk cat repeatedly enters a roof, it has probably learned that the location provides safety. Blocking one entrance while leaving food nearby may cause it to search for another opening. The solution must consider the reason for the behavior. Remove accessible food. Wait until the animal has left. Seal all possible entry points. Avoid trapping young inside. A problem-solving animal requires a thoughtful solution. Punishment often fails because the reward remains. A civet driven away from a fruit tree may return when people leave. One frightened by noise may simply change the time of its visit. The animal is constantly adjusting. Its intelligence also affects conservation research. Camera traps may record some individuals more often than others because bold animals approach equipment while cautious ones avoid it. Trapping studies may underestimate animals that quickly learn to recognize cages. Researchers must account for these differences. An animal that is never seen is not necessarily absent. It may simply be better at avoiding observation. This secretive intelligence has allowed civets to live beside humans for generations without becoming fully known. People may hear footsteps on a roof, find half-eaten fruit, or glimpse a long tail disappearing over a wall. The animal studies our routines while we barely notice its own. In a strange way, the civet may understand parts of human behavior better than humans understand the civet. It knows when houses become quiet. It recognizes the sound of dogs, doors, and vehicles. It learns where people leave food. It knows which paths are dangerous and which shadows provide cover. This knowledge is not abstract. It is precise and useful. The musk cat does not plan years into the future, build machines, or use language as humans do. But intelligence should not be measured only by human abilities. For the civet, intelligence means remembering where the figs ripen, recognizing the scent of arrival, solving the problem of a closed route, and surviving in a landscape that changes every night. That is enough. As darkness settles over a village, a civet waits in a tree beyond the last house. A light switches off. A dog becomes silent. The animal remains still for several more minutes. Then it begins to move. It follows a route it learned weeks ago, crosses a wall at the safest point, and avoids the open road. What looks like instinct from a distance may be something more subtle: memory, patience, observation, and choice working together. In the next part, we will travel across Africa and Asia to meet the many different animals called musk cats and discover how civets have adapted to forests, grasslands, mountains, wetlands, and cities. The many faces of the musk cat. The name musk cat sounds as though it belongs to one animal. In reality, it is a loose and sometimes confusing name used for several different civets and civet-like mammals. Some are small enough to move lightly along thin branches. Others are large, powerfully built, and more comfortable on the ground. Some live in humid rainforests. Others cross dry savannas, plantations, mountain forests, wetlands, and even the edges of crowded cities. They share certain features, but each species has followed its own evolutionary path. One of the most familiar is the Asian palm civet. It has a long body, short legs, a pointed face, and a tail almost as long as the rest of the animal. Its coat is usually grayish, brown, or dark, with facial markings that can resemble a mask. This species is highly adaptable. It lives in forests, orchards, plantations, villages, and urban areas across parts of South and Southeast Asia. It eats fruit, insects, eggs, small animals, and food found near human settlements. Its ability to climb makes trees important, but it also travels confidently along the ground. The Asian palm civet is the animal most strongly associated with kopi luwak coffee. Yet this famous connection represents only a tiny part of its natural life. In the wild, it is not a coffee-producing machine. It is a flexible omnivore and an important seed disperser. Another remarkable species is the African civet. The African civet looks heavier and more dramatic than the Asian palm civet. Its coat carries bold black and white markings, including spots, stripes, and dark bands. A line of longer hair runs along the back and can rise when the animal feels threatened. This raised crest makes the civet appear larger. The African civet spends much of its time on the ground and lives across a wide range of habitats south of the Sahara, including woodland, savanna, shrubland, and forest edges. It is also famous for the natural civet secretion historically collected for perfume. Its strong scent glands are used for communication, just as in other civets. The bold coat may help with camouflage by breaking up the body's outline in patchy light. The African civet's diet is broad. It eats fruit, insects, rodents, reptiles, frogs, carrion, and sometimes toxic or unpleasant animals that many predators avoid. This flexible feeding behavior helps it survive in changing seasonal conditions. Then there is the small Indian civet. As its name suggests, it is more lightly built than some of its relatives. It has a narrow body, a pointed face, and a long tail marked with dark rings. Its coat is usually covered in small spots or lines. The small Indian civet lives across parts of South and Southeast Asia. It often uses open woodland, scrub, farmland, villages, and forest margins. It is mainly nocturnal and usually searches for food on the ground. Its diet may include rodents, insects, fruit, reptiles, and birds. Because it sometimes enters human settlements, it can be seen crossing roads, moving beside buildings, or searching near rubbish areas. The large Indian civet is a different species despite the similar name. It is bigger, darker, and more robust. It has distinct stripes on the neck and a long, banded tail. This civet prefers forested landscapes but may also use nearby grassland or cultivated areas. Habitat loss and hunting have reduced its populations in some regions. Like many civets, it is difficult to study because it is active at night and avoids people. Another unusual member of the group is the binturong. The binturong is sometimes called the bear cat, although it is neither a bear nor a cat. It is one of the largest civet relatives and has thick black fur, small rounded ears, and a powerful body. Its most remarkable feature is its tail. Unlike the tail of most civets, the binturong's tail is prehensile. This means it can grip branches and help support the animal while climbing. Among carnivorous mammals, a truly prehensile tail is extremely unusual. The binturong spends much of its life in trees in the forests of Southeast Asia. Its movements can look slow and deliberate, but its strong limbs and gripping tail make it a skilled climber. It eats large amounts of fruit, especially figs, and plays an important role in seed dispersal. The binturong is also famous for a scent that many people compare to hot buttered popcorn. This strange odor comes partly from a chemical compound also associated with the aroma of cooked popcorn. To another binturong, however, the smell is not a novelty. It is part of scent communication. The spotted linsang is even more delicate in appearance. It has a slender body, a very long tail, and striking dark spots. It moves gracefully through forests in parts of Asia. For many years, linsangs were grouped closely with civets because of their similar appearance. Modern genetic research has helped scientists better understand their position within the carnivoran family tree. This shows how scientific classification can change. Animals are first grouped according to visible features such as skull shape, teeth, fur, and body structure. Later, DNA evidence may reveal relationships that are not obvious from appearance alone. The masked palm civet is another widely distributed species. It has a pale face with strong dark markings, giving it a distinctive expression. It lives from parts of the Himalayas through East and Southeast Asia. It uses forests, plantations, and areas near people. Like the Asian palm civet, it is an excellent climber and eats a mixture of fruit and animal food. In some regions, masked palm civets enter roofs or fruit gardens. Their success near people comes from behavioral flexibility, but this also increases the risk of trapping, persecution, and road accidents. Some civets have extremely restricted ranges. The Eastern civet, for example, has a beautiful pattern of dark stripes and spots and is associated with forests in parts of Vietnam, Laos, and southern China. It is much less adaptable than common palm civets. Habitat destruction, hunting, and wildlife trade have placed this species in serious danger. Its rarity reminds us that not every civet can survive in plantations or cities. Some require specific forest conditions and disappear when those habitats are damaged. The Malabar large spotted civet is among the most mysterious and critically threatened civets. It was historically recorded in southwestern India, but confirmed modern observations have been extremely rare. Scientists continue to debate its current status and whether tiny populations may survive in fragmented habitats. This uncertainty reveals a difficult truth about nocturnal animals. A species can become almost invisible before humans realize how close it is to extinction. Rare civets are hard to locate because they leave few signs and may live in dense vegetation. Years can pass without a confirmed photograph. The absence of evidence does not always prove extinction, but it can signal an urgent need for surveys and habitat protection. The Sulawesi palm civet lives only on the Indonesian island of Sulawesi. Island species are especially interesting because isolation allows evolution to produce unique forms. But limited distribution also makes them vulnerable. A large fire, disease outbreak, hunting pressure, or rapid habitat loss can affect much of the entire population. Islands often contain animals found nowhere else on Earth. Protecting them means preserving not only individuals but entire branches of evolutionary history. The otter civet is another extraordinary species. Its body is adapted to wet environments, and it lives near rivers, swamps, and streams in parts of Southeast Asia. It has a broad muzzle, small ears, and features that help it move around water. Despite its name, it is not an otter. Its semi-aquatic lifestyle developed independently, another example of unrelated animals evolving similar features when facing similar environmental challenges. Wetland civets may feed on fish, crabs, frogs, aquatic insects, and other small animals. Because wetlands are frequently drained, polluted, or converted into farms, species that depend on them can decline rapidly. The diversity of civets reflects the diversity of their habitats. Forest canopies favor climbing, balance, and long tails. Savannas favor ground travel, camouflage, and broad diets. Wetlands favor swimming and hunting near water. Human settlements favor caution, memory, and behavioral flexibility. Evolution does not aim toward one perfect civet. Instead, each population is shaped by local conditions over many generations. This is why body size, coat pattern, diet, and movement differ from one species to another. Even within the same species, populations may behave differently. A palm civet living deep in a forest may avoid people completely. Another living near a city may use rooftops every night. One population may depend heavily on figures. Another may eat cultivated fruit, rodents, or food waste. Such differences are not always genetic. Many are learned responses to local environments. Scientists study civet diversity through field observations, camera traps, skull and tooth measurements, genetic analysis, and museum specimens. Museum collections can preserve evidence from animals recorded more than a century ago. Researchers may compare old specimens with modern populations to study changes in body size, distribution, and genetic diversity. DNA has become especially valuable. A small sample of hair, tissue, or droppings can help identify a species. This is useful when animals are never seen directly. Genetic evidence can also reveal whether populations are connected or isolated. In wildlife trade investigations, DNA may help determine which species an animal product came from. This can support law enforcement and conservation. Droppings are another important source of information. They can reveal diet through seeds, hair, insect remains, and genetic traces. Hormones in fecal samples may provide clues about stress or reproduction. To a researcher, a civet dropping is not simply waste. It is a record of where the animal has been, what it has eaten, and sometimes which individual left it. Camera traps provide a different kind of record. A civet walks past an invisible sensor, and the camera captures a photograph or short video. The markings on the coat may help identify species or even individuals. Over time, hundreds of images can reveal activity patterns, habitat preferences, and interactions with other animals. One image may show a civet carrying food. Another may record a mother with young. A third may capture a rare species in a place where scientists did not know it still survived. Such photographs can transform conservation plans. The broad label musk cat may be convenient, but it can hide this incredible diversity. It can make several distinct species sound like one familiar animal. Understanding the differences matters because conservation must be specific. A widespread Asian palm civet may need protection from cruel coffee production and road traffic. A rare forest civet may need strict habitat preservation and anti-poaching patrols. A wetland species may depend on clean rivers and intact swamps. One solution will not fit them all. There is also a deeper lesson here. Animals do not need to be famous to be important. Most civet species will never become household names. Many people living near them may see them only once or never at all. Yet each species occupies a particular place in its ecosystem. It carries seeds, eats insects, hunts small animals, and becomes food for larger predators. Remove one species, and the change may spread through the environment in ways that are difficult to predict. As night falls across Africa and Asia, many different civets begin to wake. An African civet steps through tall grass. A binturong grips a branch with its tail. An otter civet moves along a dark stream. A palm civet crosses a village roof. Far away, a rare striped civet remains hidden in a shrinking forest. They are connected by ancestry, scent, and the darkness in which they live. But each one represents a unique solution to the problem of survival. In the next part, we will look at the relationship between musk cats and humans, from ancient stories and traditional beliefs to modern cities, wildlife tourism, and the difficult question of whether a civet can ever truly become a pet. Between wildness and the human world. For thousands of years, humans and musk cats have lived close to one another without ever fully sharing the same world. People built villages near forests, planted fruit trees, stored food, and raised chickens. Civets watched from the darkness. They learned the sounds of doors, footsteps, dogs, cooking, and human voices. When night arrived and the houses became quiet, they sometimes entered this new landscape in search of food and shelter. This long relationship has created curiosity, conflict, myths, and misunderstanding. In some cultures, civets have been respected as mysterious creatures of the night. Their secretive behavior, strong scent, shining eyes, and ability to appear suddenly near homes made them seem unusual and almost supernatural. An animal that is rarely seen can easily become part of folklore. People may tell stories about civets predicting events, carrying messages from the forest, or possessing unusual powers. In other places, they are viewed mainly as pests because they take fruit, enter roofs, or attack poultry. Both views simplify the animal. The musk cat is neither a magical spirit nor a villain. It is a wild mammal responding to opportunity. When a civet enters a garden, it is usually following scent. Ripe mangoes, bananas, papayas, coffee cherries, food waste, eggs, and small animals all create powerful signals. The animal does not understand property. It does not know that fruit belongs to a farmer or that a roof belongs to a family. It only recognizes food, safety, and familiar pathways. This is why conflict often begins where human resources overlap with wildlife needs. A fruit tree beside a house may become a regular feeding site. A gap beneath the roof may resemble a hollow tree. A poultry enclosure may contain prey that is easier to catch than anything in the forest. Once the civet finds such a place, memory encourages it to return. People sometimes try to solve the problem by shouting, throwing objects, using poison, or setting traps. These methods can injure the animal, endanger pets and children, and fail to address the reason it came. If food remains available, another civet may eventually take its place. A better solution begins with removing the attraction. Rubbish should be stored in secure containers. Fallen fruit should be collected. Poultry should be protected with strong wire and closed shelters at night. Branches touching roofs can be trimmed where appropriate. Openings into buildings should be sealed only after making certain that no animal remains inside. This is especially important during breeding periods. A mother civet may leave her young hidden in a roof while she searches for food. If the entrance is closed while she is outside, the babies can become trapped. The mother may attempt desperately to return, while the young suffer from hunger and dehydration. Humane removal requires patience and careful observation. The civet should be allowed to leave voluntarily whenever possible. Once the building is empty, entry points can be repaired. Relocation is often treated as a simple solution, but it can create new problems. A civet moved far away may find itself in unfamiliar territory. It will not know the location of water, food, shelter, predators, roads, or rival animals. The new area may already belong to another civet. The relocated animal may be chased, injured, or forced to travel long distances. Some attempt to return home and die while crossing roads or settlements. For these reasons, wildlife specialists often prefer exclusion and prevention over distant relocation. Living close to wild animals requires understanding their behavior, not simply moving them out of sight. The question of keeping a musk cat as a pet is even more complicated. Young civets can appear gentle and appealing. They may have large eyes, soft fur, curious behavior, and small bodies. Videos on social media sometimes show them eating fruit, climbing furniture, or resting beside humans. These images can create the impression that civets make unusual but manageable pets. The reality is very different. A musk cat is not domesticated. Domestication is a long evolutionary process in which humans selectively breed animals over many generations for traits such as reduced fear, social tolerance, and predictable behavior. Dogs, for example, have lived and evolved alongside humans for thousands of years. Civets have not undergone the same process. A civet raised by people may become familiar with its caretaker, but familiarity is not domestication. As it matures, its natural instincts become stronger. It may scent mark furniture and walls. It may become active when people are trying to sleep. It may scratch, bite, climb curtains, enter cupboards, or defend food and resting spaces. Its odor can be intense. Scent marking is not a behavior that can simply be trained away. It is part of how the animal communicates and understands territory. A home also cannot provide the complexity of a natural range. In the wild, a civet may explore trees, streams, vegetation, and many feeding sites. It chooses when to climb, hide, rest, hunt, and move. Inside a house or cage, those choices disappear. Lack of stimulation can cause frustration and abnormal behavior. The animal may pace, overgroom, bite objects, become aggressive, or withdraw completely. Diet is another challenge. Civets are omnivores and may require a varied combination of fruit, insects, animal protein, and other foods depending on the species. Feeding only bananas, coffee cherries, pet food, or household leftovers can cause nutritional problems. Veterinary care may also be difficult to find. Most veterinarians are trained primarily to treat domestic animals. A civet may require a specialist with knowledge of exotic or wildlife medicine. Handling a frightened civet can be dangerous for both the animal and the person. There are also legal issues. In many countries, keeping native wildlife without permission is illegal. Some civet species are protected, while others require licenses, documentation, or special facilities. Wildlife laws can change, and regulations vary greatly between regions. Even where ownership is technically allowed, legality does not guarantee good welfare. The exotic pet trade can create serious conservation problems. When people want unusual pets, traders may capture young animals from the wild. Mothers may be killed or separated from their offspring. Animals are transported in cramped containers, often with little food, water, or ventilation. Many die before reaching a buyer. Those that survive may be sold without accurate information about species, age, health, or origin. A single attractive video can therefore encourage a chain of suffering far beyond what the viewer sees. Wildlife tourism can produce similar contradictions. Some facilities allow visitors to hold, feed, or photograph civets. These encounters may be presented as educational or conservation-focused. But constant handling can be stressful for a nocturnal animal that naturally avoids close contact. A civet awake during the day for tourists may be prevented from following its normal sleep cycle. Visitors should ask careful questions. Where did the animals come from? Can they hide from people? Are they forced to interact? Do they have space to climb and explore? Does the facility support real conservation, or does it mainly use animals as entertainment? Responsible wildlife centers minimize direct contact and allow animals to behave naturally. The best encounter with a civet may be no encounter at all. A camera trap image, a distant nighttime observation, or a brief glimpse in the wild can reveal the animal without controlling it. True appreciation does not require touching. Scientists and conservationists often work with local communities to improve coexistence. Education can help people recognize civets, understand their ecological role, and respond safely when one enters a building. Community reports can also provide valuable information. Residents may know where civets cross roads, which fruit trees they visit, or where hunting occurs. This local knowledge can guide research and conservation. Humans are not separate from the civet's environment. Our roads, farms, gardens, waste, pets, and buying choices all influence its life. Choosing not to buy products made from caged civets is one form of protection. Supporting cruelty-free perfumes and avoiding questionable kopi luwak reduces demand for exploitation. Protecting forest corridors is another. Even small areas of vegetation can help civets move safely between feeding and resting sites. The relationship between humans and musk cats does not have to be based on fear or ownership. It can be based on distance, respect, and practical cooperation. Imagine a quiet house near the edge of a tropical forest. Late at night, a civet walks along the garden wall. It pauses near a fruit tree, smells the air, and looks toward the dark roof. The rubbish is secured. The roof openings are sealed. The poultry enclosure is strong. There is no easy reward inside the house. The civet turns toward the forest instead. It disappears between the trees, carrying seeds from the fruit it ate earlier. The people remain safe. The animal remains wild. This simple moment represents one of the best possible relationships between humans and wildlife. Not possession, not conflict, but peaceful coexistence. In the final part, we will bring together everything we have learned and discover why protecting the mysterious musk cat also means protecting forests, biodiversity, and the hidden nighttime world on which countless species depend. Why the musk cat still matters. The musk cat rarely stands at the center of attention. It is not as powerful as a tiger, as enormous as an elephant, or as instantly recognizable as a panda. It does not roar across the forest or gather in large herds. Most people may live their entire lives without seeing one in the wild. Yet every night, while much of the human world sleeps, civets continue performing quiet tasks that help tropical ecosystems remain alive. They carry seeds. They eat insects and small animals. They become prey for larger predators. They move between trees, streams, farms, and forest fragments, connecting places that might otherwise remain separated. Their importance is not measured by how famous they are. It is measured by the relationships around them. A forest is not simply a collection of trees. It is a living network made from plants, animals, fungi, water, soil, microbes, climate, and countless interactions. Remove one part, and the entire system may adjust. Sometimes the change is small. Sometimes it spreads outward in unexpected ways. When a musk cat eats fruit and later deposits the seeds elsewhere, it participates in forest renewal. Some seeds fall in poor locations and never grow. Others are eaten by insects or destroyed by fungi. But a few survive. One may land in moist soil near an opening in the canopy. Rain softens the ground. A root emerges. A shoot slowly rises toward the light. Years later, that seed may become a mature tree producing fruit of its own. Birds may nest in its branches. Insects may feed on its leaves. Small mammals may shelter in its hollow trunk. Its roots may hold soil in place during heavy rain. All of this can begin with one animal carrying one seed through the darkness. Seed dispersal is especially important in damaged landscapes. When farmland is abandoned or a forest begins to recover after disturbance, animals can help plants return. Birds, bats, primates, rodents, and civets transport seeds from surviving vegetation into open areas. Without these natural carriers, forest recovery can be much slower. The musk cat is therefore not only a resident of the forest. It can also help rebuild it. This does not mean civets can repair every destroyed habitat. If forests are cleared across enormous areas, if seed-producing trees disappear, or if animals are hunted until very few remain, the system begins to break down. Recovery requires enough surviving life to begin again. That is why protecting animal populations before they become critically rare is so important. Conservation often becomes most visible when a species is close to extinction. By then, protection is more difficult, expensive, and uncertain. It is far better to preserve healthy habitats and connected populations while they still exist. Some civet species remain relatively widespread. This can create the dangerous idea that they need no attention. But common animals can decline. A species may still exist across a large region while disappearing from many local areas. Roads, hunting, plantations, trade, and forest fragmentation can gradually reduce populations without creating one dramatic moment. Because civets are nocturnal and secretive, these declines may remain unnoticed. People may assume the animals are present simply because they once were. Camera traps, genetic surveys, community reports, and long-term research help reveal what is really happening. Conservation begins with knowledge. Scientists need to know which species live in an area, how many remain, what habitats they use, and what threats they face. This is not always easy. A rare civet may walk past a camera only once in several months. Droppings may be difficult to identify by sight. Dense forests can make direct observation almost impossible. Modern technology offers new tools. DNA collected from hair, droppings, soil, or water can reveal the presence of animals that were never photographed. Acoustic equipment can record nighttime sounds. Satellite images can track changes in forest cover. Small GPS devices can show where animals travel and which corridors they depend on. Together, these methods create a clearer picture of the hidden night. But science alone cannot protect the musk cat. Conservation also depends on law, education, economics, and local participation. A protected forest means little if hunting continues without control. A wildlife law means little if communities have no practical alternatives or if illegal trade remains profitable. Successful conservation must consider human lives as well as animal lives. People living near forests may depend on farming, timber, hunting, or wildlife-related income. Telling them simply to stop is rarely enough. Better solutions may include sustainable agriculture, alternative livelihoods, compensation for crop losses, wildlife-friendly tourism, and community-managed forests. When local people benefit from protecting wildlife, conservation becomes more durable. Communities can also act as the first defenders of civets. Residents may report illegal traps, protect den trees, reduce road speeds, or help rescue animals from buildings. Farmers can use secure poultry enclosures instead of poison. Consumers far away also have influence. The choices made in shops, cafes, and online markets can affect animals thousands of kilometers away. Buying questionable kopi luwak may support farms where civets are confined. Purchasing wildlife products may encourage capture and trade. Choosing cruelty-free fragrances and avoiding experiences that use wild animals for handling or photographs reduces demand for exploitation. No single purchase will save an entire species, but markets are built from repeated choices. When enough people ask where a product came from, industries are forced to respond. The history of Civet perfume demonstrates this possibility. For centuries, natural civet was considered valuable and difficult to replace. Today, synthetic fragrance molecules can produce similar effects without requiring secretion from captive animals. Science created an alternative, but public concern helped make that alternative meaningful. The same principle can guide other industries. Luxury should not depend on suffering. Rarity should not be treated as permission to exploit. An expensive product is not automatically a valuable one. The living animal is more remarkable than anything made from it. A civet scent gland is part of a communication system refined by evolution. Its digestion supports seed dispersal. Its nighttime intelligence allows it to remember routes and survive beside humans. Reducing that animal to perfume paste or processed coffee hides the most interesting parts of its story. The musk cat is valuable because it is alive and connected to its environment. Protecting it also protects other species that share the same habitat. A forest corridor preserved for civets may also help porcupines, wild cats, pangolins, frogs, snakes, and birds. Clean wetlands maintained for an otter civet may support fish, insects, amphibians, and local communities. This is known as an umbrella effect. By conserving the habitat required by one species, we often protect many others at the same time. Civets can also serve as indicators of ecological health. Their presence may suggest that an area still provides food, cover, and some degree of connectivity. Their disappearance can warn that hunting pressure or habitat damage has become severe. No single species can describe the condition of an entire ecosystem, but each adds information. The night itself deserves protection. Artificial light is spreading across the planet. Roads, buildings, industry, and cities are brightening places that were once naturally dark. For humans, light often represents safety and progress. For nocturnal animals, it can change feeding, movement, communication, and exposure to predators. Protecting darkness does not require eliminating all light. Thoughtful design can reduce unnecessary brightness. Lamps can point downward. Motion sensors can limit the time lights remain on. Warmer, less disruptive lighting can be used where appropriate. Dark corridors can be preserved beside forests and rivers. These changes benefit not only civets but bats, insects, birds, and even human sleep. The story of the musk cat is therefore part of a much larger story. It is about how humans share the planet with creatures that live differently from us. We are active mainly during the day. Civets belong largely to the night. We communicate through words and images. They rely heavily on scent. We reshape landscapes quickly. They adapt through behavior and evolution, but only within limits. Our worlds overlap, even when we do not see one another. A civet crossing a road may never understand what a vehicle is, but the person designing the road can understand the civet. That difference gives humans responsibility. We can build wildlife crossings. We can protect trees beside roads. We can enforce speed limits in important habitats. We can secure waste, refuse cruel products, and preserve forest connections. The civet cannot make these decisions. We can. Responsibility does not mean that humans must never use land or resources. It means recognizing consequences and reducing avoidable harm. Coexistence is rarely perfect. There will still be orchards, roads, houses, and wildlife conflicts. But knowledge allows better choices. A farmer can protect chickens without poisoning every predator nearby. A homeowner can close a roof entrance without trapping a mother away from her young. A traveler can observe wildlife without holding it. A perfume maker can create beauty without animal suffering. A coffee drinker can reject a product whose luxury depends on captivity. These actions may seem small, but conservation is often built from small actions repeated across large numbers of people. Now imagine the forest one final time. Night has settled over the canopy. Rainwater rests on broad leaves. Somewhere in the distance, insects create a steady rhythm. A musk cat wakes inside a hollow tree. It stretches, listens, and lifts its nose toward the air. There is fruit ripening nearby. The animal steps onto a branch. Its tail moves gently for balance. Its eyes reflect a faint trace of moonlight. It follows a route known from memory. Along the way, it pauses at a familiar tree and examines a scent mark. It drinks from a shallow stream. It catches an insect beneath the leaves. Later, it finds the fruit. The civet eats slowly, swallowing the soft pulp and several seeds. Then it continues through the darkness. By dawn, those seeds will have traveled far from the tree where they began. The civet will return to shelter. The forest will become bright again, and its hidden nighttime journey will end. But the effects of that journey will remain. A scent mark waits for another civet. An insect population is slightly changed. A predator may follow the trail. Seeds rest in a new patch of soil. This is how ecosystems are maintained, not only through dramatic events, but through countless quiet movements repeated night after night. The musk cat reminds us that mystery does not disappear when science explains it. Understanding the civet's glands, senses, diet, evolution, and behavior does not make the animal less extraordinary. It makes it more extraordinary. A creature once known mainly for perfume and unusual coffee becomes something far richer. An ancient survivor, a skilled climber, a chemical communicator, a devoted mother, an adaptable problem solver, and a gardener of the forest. Perhaps tonight, somewhere beyond the lights of a village or beneath the branches of a tropical tree, one is moving silently. No audience watches it. No camera records it. It simply continues its life, following scent and memory through the dark. And sometimes, the greatest way to respect a wild creature is not to capture it, own it, or turn it into a luxury product. It is to leave enough forest, enough darkness, and enough freedom for it to remain wonderfully wild.